Good afternoon, everyone. Very good afternoon to all my peers, mentors, and students from all across our great nation. So, we progress further on our journey of the one of the most versatile subjects in UPSC or across the universe, that is geography. So, brief recap of the past lecture which we have discussed. We had discussed a lot about the universe, our solar system, a lot of planets, a lot of asteroids, and recently there have been news about various asteroids trying to brush past or trying to strike the Earth, but fortunately we are still alive, and humans are not going to get extinct for quite some time unless and until they exploit all the resources of the Earth. So, jokes apart, now we'll come to the real topic. We have discussed the universe in general. This is again one of the uh, precursors. This topic is one of the precursors to what we are going to discuss finally, starting with the geography optional, the topics. So, this is going to be very interesting subject. It might be tricky for someone or some people who have no idea what the 6th standard NCERT or the 7th standard NCERT used to say. And for that, I'll be covering with my utmost efforts, and I'll be trying to make you understand with interactive infographics and vivid colors, and you might find it funny, you might find it ludicrous, I don't know, but I'm trying to apply a unique different approach so that everything becomes streamlined and easier for you, so that even if you, after viewing the lecture, even if you go back and pick up the NCERT or just download the PDF, which is free of cost from our NCERT, ncert.nic.in, so it doesn't feel boring, and you instantly, impromptu, you connect with the teaching or with the sayings that I have been delivering in the lectures. So now, out of the solar system, we are going to focus on the only habitable planet which we have found till now, that is Earth. As you know, about two-thirds of our Earth is covered with water, and that is why it is known as the blue planet. And an interesting or important point which we had talked about earlier was that the rotation of the Earth is from west to east, and only two planets in the solar system, that is Venus and Uranus, they are the planets which rotate from east to west. So now, important point here which I have mentioned is that the Earth is not exactly a sphere, it is a geoid. So geoid means that this is a little flatter than on both the poles. This is a bit flat surface, so it is a bit compressed. So this is not exactly a sphere. This shape of the Earth is known as a geoid. So So we talk about the motions of the Earth. Here I have placed two GIFs. So the Earth is constantly in motion, and there are principally two types of motion of the Earth. One is the rotation of the Earth, and the other is the revolution of the Earth. So rotation of the Earth is basically this: the Earth is rotating on its axis, and it makes one rotation in 24 hours. That we all know, 24 hours makes a day. So, and another important thing is that Earth is not rotating in a vertical position. That is, its axis is not like this, it is like this. It is tilted at an angle of 23.5 degrees from the straight line. So, it is rotating like this from west to east. Similarly, like it has been shown in this GIF. And additional information I have given that it has the rotation. The speed of rotation is approximately 1038 miles per hour. It is at the equator. Now, important point to notice is that you might be wondering that I have mentioned that it is decreasing to zero at the poles. That is because if we consider a person standing here and here, the speed the speed of so at the equator, what is happening is speed will only be there. We can only tell that speed exists when actual motion forward or backward is taking place. So if a person is standing here, or whatever object, whatever building or whatever infrastructure piece we have here, so it is slowly moving ahead based on an observer's perspective. So it is moving ahead with a certain speed. But as we go towards the poles, we can see that here, if a person is here on the poles, if the person is here on the pole, he is not moving ahead, he is just rotating in circle. Obviously the earth is large enough that we don't feel the motion, so we are not revolving in circles at that particular moment of time. But actually the speed of rotation, because the person or the point is constant here, it is not moving forward or backward, the speed decreases to zero. Another explanation which we will further be discussing in another topic known as Coriolis force, which becomes very important, is that we can also a little complicated, we can also think that this circumference, this boundary of the earth is much larger than this. So since the earth is not getting dismantled, if the pole was also having a speed same as this, so the pole would move somewhat forward than the equator. So the equator has to cover a larger distance in the same time, so that this line stays constant. So if this line has to stay constant, and if the speed is the same for all, then it will be, the earth will get distorted, and a person like standing here, he will be basically cut into several parts. So since this point has to travel 360 degrees in 24 hours, so this distance as compared to the top of the north pole or the south pole, so that is why the speed here is zero. And as we go down, the speed of rotation increases, so that the point they, after rotation, after how many whatever number of rotations they exist, or they are placed, they don't move apart from each other. So that is why we have the earth, the rotation speed of the earth, it is maximum at the equator and it slowly decreases to zero at the poles. Okay, now we have discussed the first motion, that is rotation. The second motion is revolution. Revolution means that it is orbiting around the sun in an elliptical path, not in Earth. That is an important point to note. In an elliptical orbit and not a circular orbit. So it takes around approximately 365 days, but the actual length is, the actual time is 365 days, 6 hours, 9 minutes. So you see that if we forget about this 6 hours, so we are, every year we are missing out, we are neglecting an additional 6 hours. So how do we manage this addition? Where do we adjust these 6 hours? That is why, since 6 into 4 is equal to 24, so every fourth year is a leap year. So that is why February has 29 days every leap year. So in that case, when we have 366 days, so, or in simple terms, 365, we have then 365, then the next year is 365, then we have fourth year as 366. So we had minus 6 hours, minus 6 hours, so that the combined loss of 24 hours in the 4 years is compensated by 1 day, the entire 24 hours, entire 1 day. So this is the concept behind the leap year. Another point to note here is I talked about an elliptical orbit. So what do I exactly mean by an elliptical orbit is that if I have a sun, this is very basic childish drawing, but, and this we have as the earth, so the rotational orbit Those of you who have not studied ellipses in 12th, 11th and 12th mathematics, they might not be aware of this term. But fortunately, I'm an engineer, so basically, like a circle has only one focus, an ellipse has two foci. So, there's no need to go into the depth of mathematics. We are not studying engineering here. So, this means that the Earth's distance from the sun continuously varies as it revolves around the sun. So, here we can say that it is nearest to the sun, and here it is when the Earth comes here, it is farthest from the sun. And another concept you can remember, that obviously when the Earth is closest to the sun, the gravitational force exerted is inversely proportional to the radius, which means that the closer the body is to the sun, so the more gravitational force will be there, and its speed of movement, its speed of revolution will also be faster. So this was the thing. And another point which we had discussed in the last previous video was that the distance between Earth and Sun is equal to 1 astronomical unit, which is just for convenience because it is some lot of decimals and lot of different numbers are involved. So we conveniently, for multiple distances, we use 1 astronomical unit. So this basically is responsible, rotation is basically responsible for the uh, days and nights, and this is basically responsible for the seasons. So moving on. So we have discussed about day and night. Now we are going to discuss about the seasons. So seasons basically, since the Earth is revolving around the sun, again in a counterclockwise or anti-clockwise direction. So we had discussed that the Earth is tilted, and the important point to note here is, although I have in this figure the sun is shown at the center, but it is not exactly so, as the orbit is elliptical. So there are 4 important points or 4 important names, nomenclatures, which you should keep in mind. One is the summer solstice, that is 21st of June. So on 21st of June, when we say on 21st of June, this is the position or the location of the Earth on 21st of June. We'll discuss in detail how the inclination of the Earth affects the seasons also. But here you can see that the Earth is in this position, and if we see that the northern hemisphere is receiving most of the light. So that is why we have just crossed over to the July season. So it is moving towards this. We are slowly approaching the autumn season, although we don't have autumn in India because of the monsoonal characteristics of our season and our climate. So right now we have summer in the northern hemisphere, but since it is away from, it is continuously rotating also. So we have summer in the northern hemisphere, but during this time, during the summer period in northern hemisphere, there is winter in the southern hemisphere because it is far away from the sun. So now so this is what we have talked about the summer. So here we see that during summer the days are much longer than the nights. So when we slowly move to the next, when we move to the autumn season, that is in Western countries, when in UK we have the orange leaves, the maple trees, and all those you might have seen in beautiful pictures and wallpapers. And those of you who are lucky enough, you might have traveled abroad also. So the autumn equinox, this is known as equinox. This is, there are two solstices and two equinoxes. So the autumn equinox, equinox is derived from, you can relate it with the word equal. So equal means when the when the earth is in this position, that is in this position. So we can say that it is uniformly, the sunlight is reaching uniformly over the northern and southern hemisphere. So on this day, the nights, the length of night and day are equal all over the, basically the sun is overhead over the equator, it is directly shining over the equator, and the days and nights are equal. So the entire world experiences equal day and night. Then we move to the earth is constantly rotating and revolving. So now we move to the winter solstice. So on winter solstice, what happens is, now the northern hemisphere is farther away from the sun. So the northern hemisphere will experience winter, that we do in the November, December, and January months, and the southern hemisphere we have summer. So an interesting fact, if you derive from this, is that 25th December, that is Christmas, that is Christmas is celebrated in summer in Australia, but it is, when we normally associate Christmas with lots of snow and Santa Claus and all that, but it is actually summer in the southern hemisphere. So there is, generally speaking, there is no snow there. So this is the winter in this in the northern hemisphere, and in the northern hemisphere the days are shorter, because when we have observed on a general basis also, in winters the sunset, the sunrise, it occurs late and the sunset occurs quickly. So in the summer we have the day, for example, the sunrise occurs at 6 and the sunset is at 7. So in winters the sunrise is somewhat at 7 and the sun sets around 5. So the important point is that the days become much shorter than the nights in the northern hemisphere, but it is opposite in the southern hemisphere. Then we rotate and we come to the spring season. So this is the spring equinox, 21st March. So now again equinox, again it is behind the sun if we observe. So again if I shine the torch, so again the sun is equivalent, it is overhead, it is over at the equator, and so the days and nights become equal. And again we'll be discussing in the following slides about the various important latitudes, other important definitions will be coming across. So like I've mentioned here, it is summer in the northern hemisphere. So again in Hindi you might have come across terms such as Uttarayan and Dakshinayan. So what is happening is, 25th December, if we, actually the earth is moving and the sun is constant, but if we move, if we keep the sun as constant, if we keep the earth as constant, then the sun will appear to move, and the sun will appear to move from from December onwards, it will appear to move from south to north. We are approaching summer, and from equinox, the autumn equinox onwards, it will move towards the northern hemisphere. So it is making two, it is crossing the equator twice in 1 year. So what is happening is, if I draw here, this is the center of the earth. So if we travel from the spring equinox, so the sun is if this is the Earth, we are taking Earth as constant here, and now we have taken Sun as moving. So after we reach the spring equinox, then the sun appears to move upwards. So the sun appears to move upwards. Then after the summer solstice, this is the Tropic of Cancer, this is the Tropic of Capricorn at 23.5 degrees. At summer solstice, it again starts moving downwards. Then after the autumn equinox, it again comes in straight line with the equator. Then after autumn equinox, the sun again appears to move to the southern hemisphere, and we have winters in the northern hemisphere. And then again the cycle repeats and it moves towards the equator. So just try to again digest this concept. Once you understand in the initial part, see, a good thing will never come to you unless and until you make some effort to achieve it. It might seem a complicated concept, but once you grasp the concept, it becomes very interesting, and it answers a lot of questions which you might be having about day and night, or how the seasons are continuously varying, why there is summer in a particular season, why there is monsoon, why there is winter, or why there is autumn. So this is the basic stuff. And again, I had discussed in the earlier slides about the elliptical orbit. So when this is again the sun and this is the earth. So when this is the orbit of the earth. So when the earth is nearest to the sun, then it is known as perihelion. And when it is farthest from the sun, the term is aphelion. You can remember this from Hindi word also. Since the earth is near, it is पास, sun के पास है, तो P से perihelion. Similarly, we can also talk about the satellites, the moon. The moon is also revolving around the earth in an elliptical orbit. So when it is nearest to the earth, the term used is perigee. Again, from past we can simply remember perigee, and the farthest point is known as apogee. So similar, apogee for the sun, it is known as aphelion, and perigee corresponds to perihelion in case of moon and sun respectively. So this, I think, clears a lot of concepts we'll be further coming across. So this concept is very, especially in climatology, when we discuss the second topic of paper 1 section A, this becomes very important. So you can pause this slide, or you can listen to what I have said again and again to just grasp this concept. And in order to enforce your concept, enforce your understanding, you can further visit the NCERT, the 6th class NCERT, 7th class NCERT, and I guarantee that you will be in firm control of the situation at hand. So this was about the revolution. So moving on. So now we talk about the latitudes. So you must have already heard about terms such as latitude and longitude. But if we go by the definition, because in geography, since it is a very precise objective subject, there is very little scope for subjectivity or to study geography with different interpretations, because there is logic behind almost every concept in geography. So latitude is actually the angular distance of a point on the Earth's surface. Now what is this angular distance? Again, a little bit of maths is there. So basically we talk about degrees. When we talk about degrees, so this you can see this 0 degree, 10 degree, 20. But what what is this 20 degree corresponding to, or what reference point we can say that it is at 20 degree or a particular degree of latitude. You might have, if you have not studied maths or engineering, but in the till 10th you might have measured with the angles with of something called a D. So here we had 0, then we had 10 degree, 20 degree, like this, 90 degree, then here is 180 degree. So this was known as, in short form, to measure angles, we called it a D. So angular distance is also similar. Now this is a 3D, the earth is a 3D object. Again, when I pick up this ball, so when we consider this ball, if we consider this as the earth, and if I open it to look at the interior, and I place an axis at the center, a straight point. So if this is the center, there will be a corresponding point here similar to the D. So here, when I place an object, this is the center of the earth, and I take an angle from the center. It's a bit difficult. So if I take an angle, so an angle, if we slowly increase the angle from the equator, so we have 0 degrees, then we slowly increase the angle to this 10 degree, 10 degree, then 20, 30, 40, and slowly we arrive at the 90 degree, that is the North Pole, and similarly for the South Pole. So that is the meaning why we say that we can say that 10 degree, 20 degree, 30 degree, and finally. So this is the concept. If we are measuring actually from the center, if we consider this circumference, we are measuring the angle from the center. Again, as an illustration, if we take a center, this is the equator, and this is the 0 degree, then we slowly I move my hand outwards to 0, 10, 20, 30, 40, 50, 60, and 90 degrees, and just a little more maths. So this 0 to 90 degrees, all the angles lying between them are known as acute angles. So that is there. So again, they are known as parallels. They run in an east to west direction. They are measured. They are parallel to one another and they never meet. Now again, it is 3D. So again, you might get confused that in the 2D diagram, this 2D appearing, so they might meet, but actually on the globe, if I mark, they are, if we go like this is one latitude, this is another latitude. So they are actually parallel to one another and at equal distance from each other. So then they get shorter towards the poles, which is but obvious from the diagram here. The longest, then shortest, and obviously I talked about the speed of rotation also. It is maximum at the equator. And there are some important latitudes which you might have studied in your NCERTs if you remember. So this is the equator. Now you have to remember that these lines don't actually exist on the surface of the earth. These are only used for convenience, so that the distances, for example, when you pick up the atlas, you have to locate a particular location. You need the latitude and longitude. So latitude will tell you whether it is in the north or south direction, and longitude will tell you whether the place is east or west. So if I combine both, I'll just discuss the latitudes first and longitudes. So Tropic of Cancer is somewhere here, 23.5. This is important. This is known as Tropic of Cancer. Now, why this latitude has been important is because we talked about the equinox. So at the spring and the summer equinox, the sun is directly overhead at these latitudes. So we talked about the spring equinox. So when there is the spring equinox, then the sun is over here. When it is moving towards summer, after spring we have summer. So spring equinox, the sun is at 23.5. Actually, again, we have to keep in mind that the sun is not moving, the earth is moving. But since we are standing on the earth, we think that the earth is constant. So from our point of view, a person who is standing over here, from his point of view, the earth is moving from south to north and north to south. So the sun appears to be here. Then again, at 0 degrees in autumn, at autumn equinox, the sun is shines at equator, and at again at the winter solstice, the sun is at Tropic of Capricorn. This is the Tropic of Cancer. So again, there is an important latitude known as the Arctic Circle, that is over here, 66.5 degree north, and this is 60 degree is not visible here, 66.5 degree south. So north and south, these are important directions. These are not just math concepts. For studying geography, these are the basics. These have to be kept in mind. So these are the parallels. Now, to determine the location, another term we come across is the longitudes. These are the meridians. These are also known as meridians, and they run from North Pole to South Pole. Now again, a little bit of difference between parallels and meridians, latitudes and longitudes. Latitudes are unequal in length, longitudes are equal in length, because it is a spherical surface. So if we measure all the longitudes from here to here, so all of these longitudes will be equal in length, but these distances are equal for latitudes, but for longitudes, the distance between the two longitudes, it increases from North Pole to the equator, and then it decreases. Okay, so now for measuring time, we need to have some reference. Now, how do we exactly know? We know that at a particular position of the sun, we have 12 o'clock or 2 o'clock or 3 o'clock in the morning or 6 p.m. in the evening. So how do we arrive at that? So again, like we had taken equator as the reference, similarly for longitudes, for the convenience of determining time, we have something known as the Prime Meridian, which passes through Greenwich in London. Obviously, the Queen is from London, so from England, so everything starts there. But jokes apart, so this line, like equator was taken at 0 degrees, so this line passing through Greenwich, so Greenwich, this is taken at 0 degrees. So now the important point to note, I will come to that later also. So just discuss, when they run in the north-south direction, they measure distance east to west. Okay, so where we had discussed, they run in an east to west direction and measure distance north or south. So it is an analogy. You just have to remember that they are all concepts in geography are more or less intertwined. They are connected, joined, coalesced. They are joined together. So are equal in length, then cross the equator at right angles. Obviously, again, if I say if I take this ball, so this is not exact, this is not a right angle, but equator, if we derive, if we say this is the, if we derive a tangent, if you know, if you remember the math concept tangent, so tangent is a line which is just touching the circle. So equator is a circle, this line is the tangent, and if we are going along the longitude, so longitude is meeting the latitude, the parallel meridian is meeting the equator at right angle, so it becomes somewhat like this. Again, if I move my hand, so it becomes a right angle, so that is what it says. So we have talked about Greenwich, and again, let's come to the interesting point. So just have a look at this. The Earth makes one complete rotation of 360 degrees in 24 hours. So 360 degrees, because one round or one chakkar, so it is 360 degrees. So if I again draw a diagram, so this is 0, then this is 90, then this is 180, and then it is 270, and then it is 0, again it comes to 0 or 360 degrees. So Earth is rotating 24 hours for 360 degrees in 24 hours. So again, maths, unitary method, some things for CSAT also, revision. 24 hours it is covering in 360 degrees. So how much will the Earth cover in 1 hour? In 1 hour it will cover 360 divided by 24, that is 15 degrees. So this is important figure for the time zones which we are going to study next. So again we can derive one more thing. It is traveling 15 degrees in 1 hour or 60 minutes. So it will travel 1 degree in 60 divided by 15, that is 4 minutes. So just for reference, just for if people are interested in doing a bit of maths, so that is what I have written: 15 degrees 1 hour or 1 hour in 4 minutes. So these are the basic things about latitudes and longitudes. And here, like I was mentioning about how to locate a particular place on Earth. So if we have to locate Washington DC, so Washington DC, what we do is we have this is the latitude. We mark the latitude 39 degree north latitude. So this is the 39 degree parallel. Then we have the 77 degree west longitude. So this is the 77 degree west. We had talked about the prime meridian. This is 0. So when we move west, we have the degrees in west. The longitudes, they denote, they are mentioned in the west. And when we move towards the right, so everything, so for example, all the longitudes passing through our country, India, will have some number with degree east. Moreover, since our country lies wholly above the equator, so the suffix will be degree north. So any place in India will have some number here and some number here, and it will be degree north, degree east. So these are important things to keep in mind. Just chew on it a bit, just ingest it, just try to digest it, and you can get energy. So again we move forward. Okay. So again, important concepts of the NCERT. Now, like I said, I am also trying to cover the NCERT aspect as well, so that you don't feel left out. That straight away we have just left the ground and traveled to the space, and we have started discussing all the theories which are pertaining especially to the optional, that is the geomorphology or climatology. These are the basics which these concepts are going to be used in every dimension, not only of geography or geography optional or prelims, but your entire lives. Wherever you go, you are traveling to New York, you are traveling to Moscow, these time zones, these will make your travel more interesting. You, whenever you will travel abroad, if you haven't abroad, you will know what these concepts mean, and you will immediately without any effort, you will relate to these concepts. So we had talked about the various latitudes and longitudes. Now we have divided the earth into three basic types of zones. So this is Tropic of Cancer, this is 23.5 degree north, and this is Tropic of Capricorn, 23.5 degree south. Now why they were important, just recollect. I'll give you 5 seconds. These were important because that is the maximum apparent location of the sun's movement if we consider Earth to be static. So the sun at summer solstice, the sun will be shining directly over Tropic of Cancer, and at winter solstice, the sun will be shining directly over Tropic of Capricorn. So the apparent movement, you have to remember this word apparent. Apparent means it is relative. It just appears, the sun just appears to be moving with respect to Earth and not actually moving, because the Earth is moving. So here we have taken Earth as statics at standstill, which is not so. So the sun appears to be moving from north to south. Again I'm repeating this. So the northernmost extent of the Earth throughout the year of 365 or 366 days is the Tropic of Cancer, while the southernmost extent of the apparent movement of the sun is the Tropic of Capricorn. And since the sun is traveling between Tropic of Cancer and Capricorn, between these two important latitudes, so maximum heat reaches this region. So this region is known as the torrid zones, or we will refer to other terminologies later in our discussions. So then again we had discussed about the Arctic Circle, that is 66.5 degree north and 66.5 degree south. So here in layman terms you can say that the temperature will be neither too hot or neither too cold, because the sun is not exactly shining over like in this zone or on the south or north pole. So it is a temperate. Again, these words can also build up your vocabulary, because temperate, when we say it is tempered, in another synonym can be mild. So in layman terms, although there are various regional variation in this zone also, the climate is not uniform in these temperate zones, but in layman or in general terms we can say that this climate is temperate. And when we move from 66.5 degree north, from the Arctic Circle to the North Pole, this zone, and from the Antarctic Circle to the South Pole, this is known as the frigid zone. It is extremely cold, and the sun's rays, they reach or they don't reach, they very less insolation. Another word is insolation, that is the amount of sunlight that is reaching the surface. It is the least as compared to other latitudes in the frigid zone. So frigid, of course, you can relate to the refrigerator or freeze. So all these etymologies are there. Again, we have just considered this. Now you might be wondering, doesn't it make any difference if the earth is tilted? So you might say, isn't this point receiving, if it is tilted like this, so this area seems to be more in towards the sun, so this should be hotter as compared to equator. But ultimately, if you see this diagram also, here the sunlight, here the sunlight strikes directly, although the earth is tilted, but still this is the path which is nearest to the sun's rays. Then as we move down, as we move north or south to the equator, the insolation or the angle of the sun, of the incident sunlight, incident means, it is not incidence, it is not a derivative of incidence. Incident means the sunlight which is striking the surface, it is incident on the surface. So when we say, again if I use this torch, so although you can see from the figure that the sunlight here, the same amount of sunlight, this thickness or this area is same, but this is striking this area, the same amount of sunlight is striking a larger area. So we can say, we can assert or emphasize on this fact that the same amount of sunlight is getting distributed over a larger portion. That is why the temperature, when we go north or south from the equator, the temperature in general, there are exceptions which we will discuss in due course of time, but in general, as we move from north towards north or south of the equator, the temperature decreases with increasing latitudes. So as we are moving upwards from 0 to 90, the temperature is actually generally decreasing. We'll discuss the exceptions later. And so this is the major thing. Again, I have discussed the midday sun is exactly overhead at least once a year between Tropic of Cancer and Tropic of Capricorn. That is the torrid zone. Then the midday sun never actually shines overhead on any latitude beyond the Tropic of, beyond means between this and this, and areas lying between Arctic and the Antarctic Circle and the North Pole and South Pole respectively, they receive the least amount of insolation or the incident sunlight, or whatever sunlight they are receiving, that is distributed, the same amount of sunlight is distributed over a larger part of the area, so they are colder. Now we had discussed about the longitudes and how the Greenwich meridian has been taken as the Greenwich meridian, which is passing here through London. So all hail the Queen. So 0 degrees, it is the reference position from which the time is being measured. Now you can see these numbers. I said that in the previous slide I had mentioned that in 24 hours the Earth is covering 360 degrees angle. So in 1 hour it will cover 15 degrees. So the Earth is divided into 24 time zones of 15 degrees each. So as you can see in this figure, if it is properly visible, or I will explain, this is 0 degrees, then the next time zone is 15, then 30, then 45. So the distance between them is slowly increasing. So this is going east. All the longitudes east, all the longitudes lying on the right hand side of the prime meridian are east, denote east, and all are on the left hand side of the prime meridian, they are going to the west. So that is also how we come to the concept of the east and west, because actually if we see, the earth is round. So if I am standing here, if I am standing in Chicago, I can say the earth, that New Delhi is to the east, but I can also say that New Delhi is to my west. Why? Because the earth is round, so New Delhi, if we go around, if we go towards the west, ultimately we'll end up coming here and we'll reach New Delhi. So we can reach New Delhi from Chicago from west and from east also. So that is why, in order to avoid confusion, we take this prime meridian as the reference. And here we can see that the 180 degree, this is the international date line. Now why it is known as the international date line? Because 180 degrees is half, it denotes half of the sphere. So 180 degrees here, 180 degrees, this is also, when we move a little west, this will coincide with this line. So this, as we move east or west of this line, the day will change. I will demonstrate it with the help of an upcoming video. But the important point to note is that the time when we are moving from the prime meridian, we gain time. So for example, when we talk, if we there is 12 o'clock in London, so the time at New Delhi will be 5:30 p.m. or 17:30 hours. Because obviously, if we see, why is there a difference in the time at the two places? Because if the sun is overhead over this position, over the Greenwich medium, so this time is actually ahead. New Delhi is already ahead. So the sun has already passed. Again, we are considering Earth to be constant. The sun has already passed. It is near sunset. Here it is 12 noon. And if we go further to the Chicago, there is closer to the morning. This place is closer to the morning because the sun is yet to reach here. So for example, somewhere if 5 o'clock evening, 5 p.m. exists in this, so there may be a point here in the western hemisphere when we say that there will be 12 noon. So this is all relative and some reference has to be taken in order to avoid confusion in time. So again, just see this slide once again and try to digest the concept. And these were the east zones. Again, an important point to note here in the time zones is that you might observe that although India has a single time zone, in large countries which are covering vast expanses, for example, United States of America or Russia, there are multiple time zones. For example, if there is 12 noon on Prime Meridian, a place in this area, here the number is 3, so it will be 3 p.m. in this area, it will be 5 p.m. in this area, 7 p.m. Again, it is just for the convenience of navigation. For example, a train is moving. So if we say that here the time is, if we consider the local time, have you ever set the time on your mobile phones? It has the option of setting the time locally and automatically by your network operator. So your network operator will calibrate as you move from one state to another or from one place in India to another place in our country. So the time will be automatically calibrated to with the local time in accordance with the standard time zone of our country. So for example, if we are moving from Gujarat to Assam, obviously the local times of both these places will be different because of the difference in the longitudes. But if we say that the train is arriving, if here it is 2 p.m. and here it is 1 p.m., suppose an example, so what will we say? Is the train arriving here, train which is arriving here, will it be 2 p.m. or 1 p.m.? It will be neither of the two. It will be in accordance with the Indian Standard Time because if that happens, if we are taking the local time for the arrival of planes, of cargo, of trains, then it will be a calamity. It will be haphazard. Already the Indian railways, they are always on time. So further, if we don't have a reference time, a single point of time on which all the local times are calibrated to, there will be total chaos in the country. So here also, since the country is too large, so if the train is moving in particular area, here the standard time is taken as same. So again, but we cannot take for since it is covering a lot of longitudes, so a single time zone is not possible, because ultimately there will be a lot of difference in the local time. Here the east to west expands, or the east to west dimensions are less, much less as compared to that of Russia. So one standard time or one standard time zone is feasible for a country like India or a small country, but not a large expanding country like United States or Canada or Russia. So moving on. Again, we had already talked about the important parallels or the latitudes. So we have the Arctic Circle, Tropic of Cancer, Equator, Tropic of Capricorn. So here I have mentioned just a few icons again for relation, just for fun. And because it is very, just you try to think in other dimensions. This Cancer, this is a symbol of Cancer, that is a zodiac sign, so it represents a crab also, and this represents the Capricorn symbol, the zodiac sign. So I have just mentioned so that you can relate, it becomes a little more interesting, more vivid, more colorful. So here there is the winter solstice, that is, it is summer here and winter here. Here it is the summer solstice, this is summer here and winter here. Now important point to note, if we see this 6 months of day and 0 hours of daylight. So here we can see that because of the tilt of the earth, here this sunlight is not reaching at all. So for 6 months, there will be no sunrise, apparent sunrise in this place. It will be exactly dark, because the earth will keep on rotating until it is in this 6 month period. The earth will keep on rotating and traveling, and there is no light reaching this place. On the other hand, while the rest of the world, most parts of the world are experiencing day and night, sun is continuously shining on the North Pole, so there will be 6 months of day. Analogous to that, when we study the winter solstice, there will be 6 months of night at the North Pole and 6 months of day at the South Pole. So this is a very interesting fact. Again, just now movie came to my mind. There was a movie known as his movie known as 30 Days of Night, movie about zombies. So that takes place somewhere in Alaska. So Alaska, although this is Alaska and the sun is shining, but we can say in general, near the poles, the movie has been shot near the poles, or there has been 6 months of night, and since there is winter there extreme winter there, so the flights outside that particular area for that particular town are not available, so the people are stuck in winter, and that too with no sunrise. So the undead, the so-called undead or zombies, they have come to life and they kill and mangle and they torture the people. So this is again, all these concepts, they become very interesting when we relate to this genre or this generation also, because they are too much interested in movies too. So it's all about the tilting in the axis. Then summer, you can read this stuff, just already I have explained to you. So moving on. So again, some important facts. Sometimes a question may be asked in one or another competitive examination. Some important latitudes. We have already talked about the tropics, the Antarctic and Arctic Circle, the North Poles, Equator. So I have just mentioned 38 parallel, which is the parallel dividing North and South Korea. The two neighbors, of course, you know about Kim Jong Un, North Korea. South Korea is still a pretty decent country, and we have a deluge of K-pop stars on our TV networks these days. Anyways, so this line was chosen by the U.S. military planners. Again, a bit of history involved. Potsdam Conference after the Second World War. This you will be encountering in when you study world history, probably in Arjun Dev or Norman Lewis. So World War Two, because earlier this was under, prior to World War Two, these areas were occupied by Japan. So when Japan surrender was accepted, so the North Korea and South Korea, they came into being. But again, that, if I remember some history, if I share with you, so post the World War era, there was the Cold War era. So again, although the Japanese were exiled or they were extradited from the Koreas, the Americans and the Russians, they occupied one or the other country. So the so the northern part, since it is closer to Russia, so it was under the influence of Russia. North Korea and South Korea came under the influence of America to contain the spread of so-called communism or contain the spread of so-called capitalism. So all that, again, not going into depth in the history, world history part, but this is just the basic. One more thing which might appear strange in this is that the latitudes appear to be straight, but actually it is not so. That is why map making is a bit difficult, because map making is possible, feasible only on a 2D surface, but because the earth is round, so again, if we check the globe, if we project this 3D surface on a 2D surface, then the latitudes will appear to be curved a bit. So we'll slowly come into that aspect also. So moving on again. Now we come to the real deal, our very own precious country. Now we talk about the Indian Standard Time. Again, if you see the NCERT, this map, similar to this map, although I have tried to modify it of course so as to make it easier and not too confused. You can also visit the NCERT. So the east-west extent, we have talked about the longitudes. So the east-west extent is 97 degrees 25 east and 68 degrees 7 minutes east. So like I said, India lies in the eastern hemisphere, as with reference to the Greenwich Mean Time or the Prime Meridian. So all the latitudes, all the places within India are in the east. And similarly, the latitudes, the latitudinal extent is from 8 degree, the mainland. We're talking about the mainland, not the islands as of now. So 8 degree 4 minutes north to 37 degrees 6 minutes. So actually, this is the notation. So Tropic of Cancer is 23 degrees 30 minutes. So 30 minutes, what I mean to say, what is this 6 minutes? Actually 1 degree makes up 60 minutes. So why is this 23 degrees 30 minutes east? We have talked about 23 and a half degrees. Sorry, this is not east. My mistake. This is north. 23 and a half degrees north. This 23 degrees 30. Now again we discussed a bit of maths fraction. This is in 30 degrees. When we consider degrees, so this is 30 minutes. So when we consider minutes, the minutes range from 0 to 60. But when we consider degrees, they can range from 0 to 360. Now 30 is the half of 60. So when we consider 60 minutes make 1 degree, so 30 degree will make 1 degree makes 60 minutes, so half degree will make 30 minutes. Again unitary method, some bit of math. So we can either write 23 degrees 30 minutes north or 23 and a half degrees north. So both the terms denote the same parallel or the same latitude. These small things are going to help you go a long way, whether you are giving any bank exam, whether you are coming across any mathematical question. These small things help you discover, analyze a lot of concepts. So but the southernmost point of the country is the Pygmalion point. This is at 6 degree 45 minutes north. Below this is the Andaman and Nicobar Islands. So the latitudinal extent is below the latitudinal extent, the last point, the southernmost point, below Kanyakumari. So we have talked about Tropic of Cancer. Now Indian Standard Meridian, that is 82 degrees 30 minutes east. The time occurring, the local time on this meridian is taken as the reference time. So when we had talked about the Prime Meridian, if 12 noon is the time on Prime Meridian, the time in India, the standard time will be 5:30 p.m. How is that? Because 82 degrees 30 minutes. So when we say that 360 degrees have been traveled in 24 hours, so when we try to calculate 82.5 degrees, how much will it correspond to? So 24 upon 360 into 82.5, so it will come out to be 5.5 hours. Again 5.5 hours because it is when we 5.5 hours or 5 hours 30 minutes. Again the terminology is similar to this. We can either say 5.5 hours or we can say 5 hours 30 minutes. So that is why Indian Standard Time is considered to be plus 5:30. You might have come across this term that Kolkata corresponds to plus 5:30. Another interesting concept is, like these days, if you have been following Euro 2020, although it is 2021, so the matches, although they are being played under the sunshine, normally there is afternoon or most probably evening. In India, we are able to see only at night, whether at 9:30 or 12:30. Why is that? It is a live telecast, but like we said, the the sun has already crossed India by that time, and it is somewhere near along the European countries. So there it is still morning or afternoon or evening, but here it is night. So that is just because the earth is not as small as it looks, it is very large. So already when it is sunset in India, it is not necessary that the countries or the places west of the India will experience the same amount of sunlight or night time. So that is why in cricket telecast also we often, when there was cricket test matches, in whenever there are cricket test matches or ODIs in New Zealand or Australia, so often the live telecast in India comes early in the morning, 5:30 a.m. or 6 a.m. That is because here it is already morning. It might be 9 a.m. or 10 a.m. or 12 noon, but it is still early morning. That is because of the rotation of the earth. It is already daytime, but it is still sunrise time in our country. So here what is located again, India has a, although not as expansive as Russia or America, it still has, if we consider 68 degrees 97, it is almost 30-degree longitude difference, 30-degree difference. So it corresponds, you can calculate yourself, to a difference of about 2 hours. So again, if we are traveling from Dwarka in Gujarat to Dibrugarh in Assam, so if we take, if for example here the local time is 12 noon, here the local time will be 2 p.m. So if we take that the train is arriving here at 12 noon, so if we take this time, but according to this time the train is arriving in Dwarka at 2 p.m. So there will be a conflict in the two times, and already there are too many train crashes. I don't want to go into that. So further there will be chaos, like I said. So 2 hours, in order to calibrate or make easier the time determination, we have taken time corresponding to the Indian Standard Time. So the trains run according to the time. It passes through Mirzapur, which is also a very famous Amazon TV show. Anyways, now important thing which has often been asked in the exams, various exams, not only in UPSC, CDS, CAPF, the states through which the Indian Standard Time and the Tropic of Cancer passes. So you can see the states measure the states in the color light green. The standard meridian of India passes through these states. So how many states are there? This is UP, this is MP, this is Chhattisgarh, this is Odisha, and this is Andhra Pradesh. So you can see 1, 2, 3, 4, 5, 5 states. So often UPSC or any other competitive exams can give you an option that, for example, consider the following statements. 1, the IST passes through 4 states. Just an example. And the Tropic of Cancer passes through 7 states. Then it may pose a question, which of the above correct. So it can give you an option 1 only, 2 only, one, both 1 and 2, and D, neither, 1 and 2. So this can become a very tricky question. So you need to remember, you need to have this on the tip of your tongue. Then that 1, 2, 3, 4, 5. The IST is passing through 5 states of India. So this is incorrect option. Then if we see the Tropic of Cancer, it is passing through Gujarat, then it is passing Rajasthan, then MP, Chhattisgarh, Jharkhand, West Bengal, Tripura, and Mizoram. So we have 1, 2, 3, 4, 5, 6, 7, 8 states. So this statement is also wrong. So the correct option is neither 1 and 2. Just an example. These sort of questions are very common in competitive exams, including UPSC. So again, all the blue states, the sky blue states, they are exclusive to the Tropic of Cancer, the light green states are exclusive to the standard meridian or the IST, and these in the teal color. Teal color, from these two states, both the standard meridian and the Tropic of Cancer pass, that is Madhya Pradesh and Chhattisgarh. So this is the thing, and we can talk about, there's just a video which you can see how the international dateline works. This is very interesting concept. So I'll just let you watch this video. So this was the video. Further explanation, like we were talking about the international dateline. So let me go to one of the previous slides. So we were talking about the international dateline. So in that video, what has been mentioned is that east of the international, this, if we consider the prime meridian, this is at, if this is at 12 noon, this is at 12 midnight, because there is a difference of 180 degrees that will correspond to 12 hours. So here, just for reference, it is not that we have, it is actually daytime or nighttime, or there is Monday or Tuesday. Monday and Tuesday have been created for our convenience based on the reference of the international dateline and the prime meridian. So there is already 12 midnight. So what happens is, if there is, for example, this denotes one particular day. So there is 12 midnight to 12 midnight. So if I take a globe, again this is necessary because it is in 2D, so day and night cannot be shown accurately. So the international dateline is somewhat here. So for example, we begin from here. We start the morning, that is 12 AM from here. Then the earth is rotating from west to east, and slowly, if we consider this area to start as Monday, so Monday, it is still Monday, it is still Monday, it is still Monday, and already at that international date time, it is progressing towards the, it has progressed towards the evening. And again, when the earth has rotated 360 degrees in 24 hours, again we start to the Tuesday. But what happens is, because of our reference or the systems that we have made, what was being shown in the video was, if this is the international date line, if a point here on the east of the date line is Monday, then if we at the same time, if we move to the left of the international date time, it will be Sunday. So that is the concept of the international date line. Why? Because if we consider the time, it is 12 a.m. or if we consider 3 a.m. 3 a.m. is the time currently here. But 3 a.m., since it's the international date line, so if we have 3 a.m. on this point and 3 a.m. at this point also, but although the time is same, but we have crossed the international date line, so it becomes 3 a.m. on Sunday. This is 3 a.m. or Monday. So that is the basic concept. So for example, just an interesting example. For example, there is 31st December. There is 31st December in this part of the hemisphere. But if we on 31st December, for example, there is 12 a.m. So we are going to burst firecrackers and we are going to have a feast. But if we already we cross this line, then it is already 1 January. This date is same, 12 a.m. So we have missed our festivities. We are going to miss our festivities of 31st December, because it is already January in the Eastern Hemisphere. Again, the time is same. If we consider conceptually, time is same, but the dates have become different. So that is why whenever we talk about an airplane flying from east to west, west, so it is said that we are losing time. You might have come across a term, jet lagged. Why? In particular consonants or in particular relation to airplane or airway travel. So what happens if my circadian rhythm, I am staying in India, my circadian means that our sleep cycles, our waking and sleeping cycles are built or they are configured according to the cycle of the sun. So here, according to my place, New Delhi, the sun is rising and setting at approximately the same time. We are waking up. Those who are healthy, well and wise, they're waking up early at 6 or 7 a.m. and going to sleep by 10 or 11 p.m. So that cycle is the same every day. But now, if we fly towards, we go for vacation in America, so there is a lot of difference. Although day and night will be the same, but what will happen is our cycle, when it used to be 7 a.m. in New Delhi, it will be somewhere possible that it is 7 p.m. because the time zones have become different, and also that is because of the rotation of the earth. So now the body gets confused that at this time I am supposed to wake up, but it is 7 p.m. here and not 7 a.m. So again, if I am going to sleep at 10 p.m. here, it might again we get a 12-hour difference. So it might be 10 a.m. because we are losing time. So the body is used to going to sleep at 10 p.m. But when it is 10 p.m. here, we are going to feel sleepy at 10 a.m. here when we are supposed to start our day. So that is what is meant by jet lagging. Jet lagging, basically we need time to adjust to the new, because sunrise at this time at sunrise at this time are starting to take place at different times, but our circadian cycle, our sleep cycle is configured, or it is already corresponding to the circle, the sunrise and sunset that we used to experience in India. So that is why we we get jet lagged. So further, now we move on. So just for fun, some questions similar to UPSCs. So we know that the torrid zone falls between the tropics and Arctic and Antarctic circle. So this is incorrect. So as we move away from the equator, length of the parallel latitudes increases. So this is also incorrect. The distance between two meridians on line is maximum at the equator and zero at poles. This is correct. All meridians of longitude have equal length. So the correct answer is 3 and 4. The correct answer is 3 and 4. Moving on. The climate of a place, although we'll be discussing in upcoming topics, the climate is not necessarily affected by. We have talked about the latitudes, that as we go, as the latitudes increase, the temperature decreases. So it is not necessarily affected by. So it is affected by this. So this is not the correct option. Then this is affected by altitude and relief. Altitude means, for example, a mountainous area is obviously, a hill station is obviously going to have lesser temperature as compared to the sea level. So this affects the climate, but so this is incorrect. And continentality we'll discuss in upcoming concepts. So this is incorrect. So the correct option here will be longitude. This is an interesting question. Just think about it for 5 seconds. The total number of parallels across the globe. Most of you might be thinking 180 or maybe 90 or 360, but I'll come to the option. Just it is actually 181. I'll explain why. Again, total number of meridians. Now you will be thinking on similar terms here, that the same answer may be repeated on this, but let's check the answer first. So the answer is actually 360. So why is that? Again, a little bit of common sense maths. So when we talk about the parallels, so if we have this earth and we have equator, so it is 0 degree. So we have 1 degree latitude, 2 degree, 3 degree, and so on till 90 degrees. So 1 to 90 makes 90. Then south also we go from 1 to 90 degrees south, we get 90. And don't forget the equator, it is also, although it is 0 degree, but it will be counted as latitude, so plus 1. So that is why the answer is 181. If we consider total number of meridians, now don't get confused here also. Now I am going to take 0 degree, the prime meridian, as the example. The opposite, if I take like this, if I consider like this, if this is the prime meridian, visualize this as a 3D object. Okay, so the prime meridian will appear to be curved like this. This is 0 degrees, and the opposite, the back side, that is the international date line shown in dotted portion, it will be at 180 degrees. Okay, just for reference, if this is Greenwich Mean Time is passing through here 0 degrees, so the place opposite to it will be 180 degrees. So when we go from 1 to 180, so we have 180 longitudes, number of longitudes is 180. Then we start from 181 to, this will become 360. So 181 till 360, it becomes 180 and is 180. Just notice that in the first count, I have not included the prime meridian because I have started counting from 1 degree. That is from 1 to 180. Then I have counted from 181 to 360. That is same as 0 degrees prime meridian. So this is all visualization. Just try to visualize it. So the total number of longitudes is, or the imaginary meridians are 360. Again, the latitudes, some important latitudes, like we have discussed about India, the Tropic of Cancer passes through how many states. So similarly, Arctic Circle, you can be asked, the Arctic Circle passes through which of these countries. So just go through the atlas and you can say that all of these countries, the Arctic Circle passes through all of these countries. So these type of questions are very common in UPSC. Okay, then this is the shape of the earth is geoid. This we have already talked. So this is the region that lies between Tropic of Cancer and Tropic of Capricorn is torrid zone. This is right. The temperature decreases from equator to pole because of the shape of the earth. And this is right. North pole is latitude. This is also right because it is latitude pertaining to 90 degrees. So check the answer. It is all. Although in the option in UPSC it will be 1, 2, 3 and 4. It will not be mentioned as all. It is rarely mentioned as all of the above. Okay, now this question was asked in UPSC 2019 prelims in the geography part. So on 21st June, just quickly recollect what was 21st June. Yes, so this was summer solstice, at which point at this date the sun shines directly over the Tropic of Cancer. So now look at the options, they might seem a bit confusing. So the sun does not set below the horizon at the Arctic Circle. So what does that mean? Does not set below the horizon. Horizon does not set below, this corresponds that there will be day. There will be 24 hours of day because it is not going to set, so there will be 24 hours of day. Okay, just let us consider these statements. On 21st June, what we had observed was that this is the sun, summer solstice. So the North Pole, the South Pole will be 6 months of dark and North Pole 6 months. So on summer solstice especially, it will be 24 hours of day. The sun does not set below the horizon at the Arctic Circle. So this is actually the correct answer. But if we consider other options also, does not set below the horizon, this is incorrect because there is no sun, there is 24 hours of night. So this option is incorrect. Then shines vertically overhead at noon on the equator. This is incorrect because this is the situation of the equinoxes. Then shines vertically overhead at the Tropic of Capricorn. Again, Tropic of Capricorn is not, it is shining directly over Tropic of Cancer. So these little things you have to keep in mind. So this is also incorrect. So we have the option does not set below. This is the explanation for that question. Again, the equator passes through which of the following countries? In here, you just have to observe the map and all these countries. These are important countries through which the equator passes. This is Ecuador, Colombia, Brazil, then Gabon, then Congo, then Democratic Republic of Congo, Uganda, Kenya, and so on. You should be now your homework in this would be to determine, look at your atlas and find out the countries, all the countries through which the Prime Meridian passes. And if you can spare some time, you can also have a look at what are the countries through which Tropic of Cancer passes, what are the countries through which Tropic of Capricorn. These 3 or 4 latitudes are important. Don't need to go through Arctic Circle also or 38-degree parallel also. Just go through this equator, Tropic of Cancer, Tropic of Capricorn, and Prime Meridian. Just have a brief knowledge. You should have a brief knowledge of the location of these countries with respect to the parallels or the latitudes. Now we come to another important topic, that is the eclipse. So an eclipse is an astronomical event, like it is written in the definition, when one object, it casts a shadow or comes in between celestial bodies. So basically it's temporarily obscured. Obscured means it is hidden. Obscured means hidden by either passing into the shadow of another body or by having another body pass between. It is a type of syzygy. Syzygy is another term. Syzygy means that 3 celestial bodies, they are in consonance or they are in congruence or they are in a straight line. So syzygy, why this is an umbrella term? Because syzygy also happens on the day of new moon and full moon. So on new moon, for example, if this is the moon and this is the earth and this is the sun. So here we can say that this is the period of the full moon for a person standing over here, or in other words, if we consider this as the earth, this is the moon and I am standing over India over here, so this is a full moon. Then as I go to the opposite and it is Delhi is exactly opposite to the position of the moon, then at Delhi, not on this position, at this position it will be a full moon, but at the position of Delhi, which is 180 degrees opposite, it will be a new moon, which we call Amavasya. So basically now when we discuss the eclipse, so here I have mentioned the solar eclipse. Basically 2 types of eclipses are there, the solar and the lunar eclipse. In solar eclipse, the sun is covered partially or wholly by the moon. Now important point is to consider is that although the moon is about 400 times smaller than the sun, but it is also the sun, but at the same time the sun is also 400 times at a larger distance. So that is why the moon and the sun appear to be of the same size, but actually the sun is much larger than both the moon and the earth. So in the case of a solar eclipse, what happens is the moon comes in between the sun and the earth. So when this happens is there are 2 types of shadows which are created here. This darker shadow is known as umbra and this lighter shadow is known as penumbra. This is the moon's orbit. So here it will, when it is in the umbra, we say that it is a total eclipse. When it is in the penumbra, we can say it is a partial eclipse. Just wait for a minute. I will also show a video to here the umbra, the shadows, fully shaded core, penumbra, partially shaded. So eclipse, there are three parts. One umbra we have discussed, penumbra we have discussed, and antumbra is also there. Is not much important. And during a lunar eclipse, only umbra and penumbra are applicable, and the total eclipse also occurs when the observer is within the umbra, and annular eclipse when the observer is within the antumbra. I'll just show you a video denoting this, which will become easier for you to understand.
A solar eclipse happens when a new moon moves between the Earth and the Sun, blocking some or all of the Sun's rays from reaching the Earth. By cosmic chance, even though the Sun is 400 times wider than the Moon, it's also 400 times farther away. Therefore, the two objects appear the same size in our sky. Astronomers are able to predict eclipses because the Earth and Moon have very predictable orbits. Why then isn't there an eclipse every month? The Moon's orbit is usually tilted a few degrees north or south in relation to the Earth. When the Moon does eclipse the Sun, it casts two types of shadows on Earth: a smaller, darker shadow known as the umbra, and a larger shadow known as the penumbra. There are four types of solar eclipses. The first and most spectacular is a total eclipse, when the Moon completely covers the Sun's surface. A total eclipse can only be seen if you're standing within the umbral shadow. That's why the imaginary line created by this shadow as it races across Earth is known as the path of totality. People within the penumbral shadow see only a partial eclipse, the second type. From this view, outside the path of totality, the Moon passes in front of the Sun off-center, never fully covering its surface. Third, an annular eclipse occurs when the Moon passes directly in front of the Sun. However, unlike a total eclipse, the Moon appears too small to fully cover the Sun. The Moon's orbit is elliptical, so sometimes it's closer to Earth and sometimes it's farther away. Last, a hybrid eclipse is when the Moon's position between the Earth and Sun is so finely balanced that the curvature of the Earth plays a role. The Moon will be farther away from some parts of Earth along the eclipse's path, resulting in an annular eclipse. In other parts, the Moon will be just close enough to fully cover the Sun, resulting in a total eclipse. While a total solar eclipse happens somewhere on Earth every year or two, any given point on Earth experiences the event only about once every 400 years. We interrupt this video for an important safety announcement. Looking directly at the Sun, even during an eclipse, can cause permanent eye damage. Fortunately, there are ways to enjoy an eclipse safely. The easiest is to use certified eclipse watching glasses, which are shaded thousands of times darker than typical sunglasses. You can also look at the eclipse indirectly by making a pinhole viewer. Simply poke a small hole in a piece of cardboard. Hold the cardboard up to the Sun, allowing the Sun's image to be projected onto a flat surface. Be sure to look only at the surface and not through the cardboard. Just before the Moon completely covers the Sun, low-lying valleys on the Moon's edge will be the only spots that sunlight continues to pass through. These remaining brilliant shafts of light, known as Bailey's beads, will disappear one after another. And finally, a single bead of light remains, known as the diamond ring, signaling that you're just seconds away from experiencing totality. Once the last bead disappears and the Moon completely covers the Sun's surface, the view through your eclipse glasses will be pitch black. Totality achieved. At this point, none of the Sun's rays are reaching your eyes, and it's the only time that it's safe to take off your glasses. Remember to put your eclipse glasses back on before any of the Sun's rays start to peek through again. Any sunlight reaching your eyes, even for a few seconds, can cause serious damage. While an eclipse can last a few hours, totality typically occurs for less than 3 minutes. Animals and plants have also been known to alter their behavior during a total eclipse. Songbirds may stop singing, crickets may start chirping, and flowers may even start to close up. We won't always be able to see total solar eclipses. The moon moves about 1.5 inches away from Earth each year. It's estimated that in about 1 billion years, the moon will be too far away from Earth to completely cover the sun.
So that was about the solar eclipse. Hope you enjoyed the video. Just a disclaimer that this video, only the presentation has been created by me. This video and this video both are courtesy National Geographic. So I lay no claims over that. So basically, I think you have grasped the concept of the solar eclipse. Again, there was an important point that the why on every new moon we had talked about CCG, and why on every new moon and full moon there is no eclipse. That is because the orbit, if there is the sun is here and the earth is here, so earth, if it is has this orbit, and the moon is also here, moon is also revolving around the earth, so they are not revolving in the same plane. So there will be, the moon is revolving in a plane which is at a slight tilted angle to the orbit of the earth around the sun. So because of that angle, there will be only a few instances or few coincidences that on which the earth, sun and moon will be exactly in the same line. Every month there will be a full moon and an amavasya, but every month we cannot expect a solar or a lunar eclipse. We have talked about total eclipse, annular eclipse, and they had given a caution. They have cautioned you also not to look at a solar eclipse even if it is eclipsed, because there is an outer layer or corona which we have discussed earlier also, which is always mostly visible except from the total eclipse, in which for 3 minutes the sun will completely disappear. So there are special glasses which can be used, or if you are do it yourself kind of person, then you can try that pinhole to the cardboard also. So this was about the solar eclipse. Just to video more the lunar eclipse also. The lunar eclipse is much more interesting because it experiences a change in color. So
A lunar eclipse happens when the Earth blocks some or all of the sun's direct light from reaching the moon. This cosmic event only takes place during a full moon, which happens once every 29.5 days, or the length of one full orbit of the moon around the Earth. So why don't we have an eclipse every month? The moon's orbit is tilted a few degrees in relation to the Earth, so the Earth, moon, and sun don't always align. When the Earth does eclipse the sun, it casts two types of shadows on the moon. A larger shadow, known as the penumbra, and a smaller, darker shadow, known as the umbra. There are 3 types of lunar eclipses. The first is a total lunar eclipse, when the sun, moon, and Earth are in perfect alignment and the moon falls within the Earth's umbral shadow. Total lunar eclipses are the most striking of the 3 types because they turn the moon a sunset red. While shorter blue wavelengths of light are scattered outward by the Earth's atmosphere, longer red wavelengths are refracted or bent inward toward the moon, making it appear red. The brightness of the moon's red glow depends upon how much dust and clouds are in the Earth's atmosphere. Following volcanic activity, ash can block out enough light to render the moon a darker red or even near black. A partial lunar eclipse, the second type, occurs when the Earth, Moon, and Sun don't perfectly align, so only part of the Moon passes into Earth's umbra. Earth's shadow appears very dark on the side of the Moon facing Earth. Last, a penumbral lunar eclipse occurs when the Moon passes through Earth's penumbral shadow. The event is so subtle that most people don't even notice. The Moon will appear just slightly darker than normal. Lunar eclipses occur up to 3 times a year and can be observed from the entire nighttime half of the Earth. Unlike during a solar eclipse, it's safe to look at the Moon with the naked eye during a lunar eclipse. It is only because of the distances of the Sun and Moon from the Earth that we are able to witness total lunar eclipses. As the Moon inches away from the Earth each year, one day, billions of years from now, the Moon will be too far away to fall completely within Earth's umbral shadow. Until then, we can occasionally enjoy seeing our own planet's shadow cast upon the largest object in the night sky.
So hope you enjoyed the video, again courtesy National Geographic, not courtesy yours truly. So the important thing to note here again is that when we talk about eclipse or the word obscure, we should say like the sun is covered. Why during a lunar eclipse the moon is not covered? That is again because a little bit of physics is involved. So basically, like the color red, out of all the colors of the rainbow, that is Vibgyor. So you should know what is Vibgyor, even if you have not studied physics extensively. So red color has the longest wavelength. So it is not scattered as much as the other colors, that is blue or indigo or violet. So since red color is the least refracted, so when the earth is coming between the sun and the moon, so again two same type shadows which are of the same name, that is umbral and penumbral. So during the umbral, the total lunar eclipse, the shadow which is cast, so now we have to remember that moon does not have light of its own, unlike the sun. Moon actually shines or appears or casts light, sheds light because of the reflection of the light of the sun. So sun is continuously, despite eclipse or not, sun is continuously casting or showering light over the moon. So what happens in this is light is still reaching the moon despite the earth being in the middle, but due to the earth in such a CCG, in such a position straight line, the blue color, because of low wavelength, it is refracted or diffracted towards the outer. Only the red light is reaching and it is being reflected. So that is what is a spectacular visual in the sky during the lunar eclipse, that is the moon appears red. Otherwise, when during the penumbra and other incidents of light, the moon, there is not much difference that is observed. So particularly when the color is changed, so again vivid, it appears vivid, it is also known as the blood moon, so it appears very rarely. So that is why the narrator at the end of the video says that we should cherish till whatever that cherish the time till we have the opportunity to visualize or be an eyewitness to the lunar eclipse when we can, because according to the Big Bang theory, the universe is continuously expanding. So the narrator also said that the moon is continuously moving away from the earth, and the you might have come across a term known as Doppler shift. So that is exactly a phenomena that is happening in the universe expansion. So one day might come, like we are taking all things these days, the environment, the water, fuel, oil, all these resources, natural resources, for granted. So one day might also come that we might not be able to be witness to the lunar eclipse at all. So again, you might have again example comes to my mind. If you have a prism, you might have done this experiment. If you pass light through the prism, because of different wavelengths of the white light, it is diffracted or refracted into different colors of light. So since red is the highest wavelength, it is refracted the least. Red appears on top, and violet, indigo, blue, the vapor appears from south to north or from bottom to top. So this was about the eclipses. So we'll conclude our session here. It was again a part of general geography. From next lecture onwards, we'll start traversing upon the path of our actual mission, that is geomorphology. So heads up, your task is cut out. You have to cooperate with me. You have to try to keep an open mind, open eyes, open ears. You might get tired. Just I'll make it as simple for you as possible. So at the end, I can conclude by a quote that the geography is an eternal landscape. Geography is an eternal landscape. It is the geography of our soul, and the outline of that soul is that thing which we keep on searching throughout our lives. So basically, a lot of philosophy and geography engaged or intertwined with each other. Obviously, again, we you can use this sentence in the introduction for your essay also. It gives a good impact. Anyways, so that was the conclusion of our discussion for today. So have a nice day, and Jai Hind.